of the B, but it's the same thing.
I like doing X's better.
Well, I mix them in there so that you know that it can obviously be something besides X.
Are you recording?
I am.
Oh.
Yeah. All right. So this is what the question looks like for number 12. I just used X's instead of B's so you wouldn't be really confused about that. But the reason why I chose different variables is so that you know that they don't always have to be X's. Okay? So we're going to have to make it equal to 0. So I'm going to add 3 to both sides. Why do we have to make it equal to 0? Is because we're finding the zeros or the x-intercepts, and that's where the y value is 0. So what this really translates to is also 6x squared minus 13x plus 6 equal to y. So it really translates to that. And so we're finding the zeros because that's where the y value is 0, is at the x-intercept. So that's the purpose. Okay?
I don't know about this.
And so now, we're going to factor this by grouping. First of all, I want to show you something that we talked about yesterday. You didn't know this when you first did the assignment, but this is kind of referencing back to yesterday. Okay? You knew you were going to factor these because that was the only technique other than the calculator that you knew how to find the x-intercepts. Okay? And so now you have multiple ways because we taught quadratic formula yesterday, which we'll work on here. Okay? And so I'm going to show you something that'll help you know why to use factor, or when to use factoring and when to use quadratic formula. And that's called the discriminant. Okay? So this is what we talked about yesterday. Where is this located? Where does this come from? Did I pull this out of thin air? It's located under the radical of the quadratic formula. Okay? And so therefore, I'm going to plug in my A, B's, and C's from the problem. Excuse me. I'm sorry. And so we have negative 13 squared minus 4 times 6. Sorry. Times 6. So obviously it looks like our number is going to be kind of big.
God bless you.
You as well. So this is 169 minus 4 times 6, which is 24. 24 times 6 is what? What is 24 times 6?
24 times 6?
Yeah. Who? 144. Thank you. Okay? So we subtract that, what do we get? Huh? What kind of number is 25? It's not prime. It's composite. What else? It's odd. So yesterday that kind of goes against some things we talked about because everyone yesterday was prime and odd, and so therefore we use quadratic formula. But this is on a factoring worksheet. And so this one is composite. Okay, it's odd. But there's one other really key thing about it. There you go. That's the key fact. If your discriminant is a perfect square, then it has the ability to factor. It has nothing to do with this composite. It has nothing to do with odd and even. It has everything to do with it being a perfect square. Okay? And so it can be used as a perfect square to factor. Now, so this is going to factor since it's a perfect square. And so our problem is the fact that this 6 is greater than 1. So what we do is we take this 6 and we multiply it to the c. And this has become x squared minus 13x plus 36 equals 0. And now we ask our questions. What multiplies to give me 36 and adds to give me negative 13? Anybody got anything?
9 and 4.
9 and 4 do it.
Negative 9 and 8.
Okay, 9 and 4 give me 36. 9 and 4 give me positive 13, so I need both of them to be negative, right? And so now here is the toughest part, because that's a process that we're pretty good at. The toughest part is to remember to, when I split the middle right here, I have to do it from the original. Okay? I can't do it from the one where I multiplied the a to the c. And so this is going to be 6x squared minus 9x minus 4x plus 6 equal to 0. So you got to do it in the original. After that, pretty simple. Factor by grouping. We can group it because it's even terms. What's the GCF inside of 6x and 9x?
3.
Almost.
3x.
There you go. Okay? And so therefore I'm left with 2x minus 3. Is that correct?
Yes.
All right, so that tells me what I need to factor out of the next one.
2.
Okay, I can factor out a 2, but that's going to give me not the...
-2.
There you go. Negative 2 is going to leave me 2x minus 3. Right? And now those are the same. And so my factor form is 3x minus 2 and 2x minus 3. Correct?
Correct.
And so now I find the x-intercepts by 3x minus 2 equals 0, 2x minus 3 equals 0, and so I have plus 2, 3x equals to 2, divided by 3, so x equals 2 over 3 for one of them. Add 3 to both sides, 2x equals 3, divided by 2, x equals 3 over 2. And those are my two x-intercepts. And so this should be written according to the problem, 2 over 3 and 0, and 3 over 2 and 0. Any questions?